Hey guys, today we're going to look at the difference between speed and velocity. So just to review from the last video, we have two different quantities that we're going to look at. The first quantity is measured only with numbers and a unit, not with a directional component. And then the last video we talked about how distance is a scalar quantity because we have a distance measurement in a number and a unit, so like 3 miles. We talked that mass is a scalar quantity because mass is measured in terms of kilograms or grams, but does not have a directional component. We talked that time is a scalar quantity because we have not figured out how to go backwards in time yet, so we can only go in one direction with time. And we said that speed is a scalar quantity. This is one of the items we're going to be focusing on today. Vector quantities are measurements that have numbers as well as a directional component. That directional component can be north, south, east, or west. It can be increasing, it can be decreasing, it can be left, it can be right, as long as it has some sort of indicator of a direction or movement. So displacement was a vector quantity. Velocity was a vector quantity, which is what we're going to focus on today in this video, and acceleration is a vector quantity. Okay, so scalar, numbers, no direction, vector, numbers with direction. So speed. Lots of information on the slide. First thing that we have to look at is the fact that speed is a scalar quantity that measures how fast an object is moving. So it can be measured in miles per hour, kilometers per hour, meters per second. Most of the time in this class, I'm going to require that you convert things to meters per second because that is going to be most useful to us in the future. There are two types of speed that we're going to look at. The first one is the average speed, which is the total distance traveled divided by the total time that it takes. And it's actually an average of all the individual speeds you travel in a given time. So if you're driving on a trip from Toledo, Ohio to Columbus, you might be traveling 25 in your neighborhood, you might be traveling 35 in a small city, you may be traveling 70 on the highway. So the average speed is all of those individual speeds averaged together. Instantaneous speed is the speed that you're traveling at any instant. It's a value that is constantly changing. So with those same examples, the 25, 35, 70, the instantaneous speed is the speed that you were traveling at any given moment. So if you're on the highway and you're cruising and listening to music, you might lose track of things and glance down and notice that you're going 80, and that would be your instantaneous speed at that moment. You would ease off the gas pedal, slow your speed back down to the speed limit, and travel on further. Okay? The easiest way to remember this, average has to be calculated. Instantaneous is the number that you see on your speedometer. Velocity is the vector quantity of speed. It's how fast you're moving and in which direction you are moving. So since velocity is the vector quantity of speed, it has to include a directional component. If you're traveling from Toledo to Columbus, you're technically traveling southeast. So you may be traveling south on the highway, but east in one development, west down a different road. Overall, your general direction would be southeast. Now, the one reason or the one way that I like to explain this, we have speed limit signs, not velocity limit signs, because on those signs, it does not give you the direction. If you're traveling down one road that happens to travel north and south, for speed limit signs, they can use the same sign on both sides of the road. If you're traveling southward, they can have a 55 mile per hour sign. If you're traveling northward, they can use the same 55 mile per hour sign. If those were in fact velocity signs, they would have to have a directional component. So you'd be traveling 55 miles per hour south or 55 miles per hour north. That can get really, really tricky when you have a road that takes a 90-degree turn, because you may be traveling south one moment and east the next, and if they used a velocity sign, they would have to have a different direction on each of those signs. So speed is distance over time Velocity is distance over time with direction. We can find velocity if we find the position time graph and calculating the slope of the best fit line. We haven't really talked about position time graphs yet, but we're going to soon. Okay, so by finding the value of the slope of the position time graph, we can find the velocity traveled. So here are the mathematical differences. In order to calculate speed, we are going to use the same variables because it's kind of confusing, but that's the way it's done. Speed is distance over time. So velocity or speed is distance divided by time. This can be measured in meters per second, miles per hour, or kilometers per hour. In this class, we're going to focus and try to use meters per second as often as we can. In order to calculate velocity, we actually have to break it up in finding the final position minus the initial position and divide that by time. Because remember, distance is adding up all the individual parts of our trip. Displacement is our beginning position and our final position being compared only. So I don't care about all the little steps in between, I care about where I start and where I end. So this little f next to this first x, that is our final position or our final location. The I next to the second x is our initial. And mathematically, this can be rewritten as delta x over t, or change in x over time. Okay? The major difference is one uses distance. This is distance. And one uses displacement. Now, generally, you're not going to have to think too hard about this because I'm not trying to trick you in terms of speed versus velocity, but you do have to be careful, especially on the assessments, because there may be some trick questions. It may say you traveled from home to school back home again and the trip took you 20 minutes. What was your velocity? Well, technically, if your displacement is 0, your velocity is 0. So just remember that that can be a possible trick question. Okay, so mathematical differences, just to recap, speed uses distance over time, velocity uses displacement over time.